All right, so we need a title for our notes today. What topic are we on? Because it says topic 23, but I'm pretty sure we're at like 25 now. Is that right? Topic 25. So topic 25, and this is called Spearman's. We're going to learn something called Spearman's rank. And so we're going to call this Spearman's versus Pearson's. Pearson's, I can spell. I can't either. I just like to psych myself up. All right. So we're going to calculate the R value, which is the Pearson's product moment correlation between week 1 and week 2. And so hopefully you already put this into list 1, and you did this in list 2, and then you did second calc 4, which did a linear regression, and it gave you an R value. Did anybody have the R not show up right away when they did the R value? Because remember last class we pressed mode on our calculators and we went down and turned on our diagnostics. So if your calculator gets cleared, that will go away, and so you have to go back to mode and turn on your diagnostics. And I must have had a typo when I did it, but you guys are getting the same thing as my answer key, which was R is equal to 0.893. So I'm going to trust that answer. Does anybody have a question about how to get that? So in today's notes, when we do this, we're going to call this R sub P, because this is the Pearson's correlation as opposed to the Spearman's correlation that we're going to talk about today. If you just write R, I'm going to assume it's R sub P, but just to differentiate today. Yes, go ahead.
Isn't it stat calc?
Stat calc, thank you. I count on you guys to tell me these things. Stat calc, you're right. Anything else?
When would you use R squared versus R?
That's a good question. R is only used for linear data, okay? And so R squared is going to come up next class when we do nonlinear regressions.
Okay.
We are going to look at some data today that's not linear, but instead of comparing R squared values, we're going to do something different, which is to calculate the Spearman's correlation. All right, reliability, let's see. So we have to talk about reliability here. They talk about two different things. They talk about retest reliability, when the same group of individuals are given the same test multiple times over time. So if you're given this exact same test, I mean, you can see that there are going to be issues with that, right? Because after a while, you just know what's on that test. And then there's also something called parallel forms reliability. And that's when different versions of a similar test are given over time. And they are considered reliable when there's a strong positive correlation. So what type of reliability is being considered here? Is this retest reliability or parallel forms reliability? What do you think?
Parallel forms.
Parallel forms, right? Because when you randomly choose these questions, you're going to get different ones each time. All right? So it's parallel forms. Because different questions each time. And then comment on the reliability. So you should have in your notes from last class, you should have that nice table that tells you how reliable this is. If you didn't pull that table out yet, all right, so because the R value was 0.893, and that is strong, and because it's a positive number, we're going to say that it is a strong positive correlation. And since it's a strong positive correlation, we can say that the test is reliable. All right, I found this next part a little bit murky, but we're going to try to get something out of it. Validity is how accurately a variable is measured in a particular aspect of a population. Content validity considers how well the field of study is covered. So if we think of the field of study as elementary mathematics, then we can consider whether this test has content validity. So would you say that this test on multiplication facts has content validity for elementary mathematics? How well does it cover that field of study? If I know somebody knows all their multiplication facts, do they know all of elementary mathematics? No, because we didn't talk about a lot of things. I mean, we didn't talk about any of the other arithmetic, right? We didn't talk about adding, subtracting, and dividing. And then, of course, we studied geometry in elementary school, all kinds of things, okay? So we would say it does not have content validity. Okay, so the test is very reliable in measuring their multiplication facts, but it doesn't have content validity as far as measuring all of their elementary mathematics.
But doesn't it also be considered the field of study of multiplication?
Yeah, so if you wanted to consider the field of study just multiplication facts, then you could say that specifically. You could.
If we get this type of question on the test, would we have to decide between the two?
I'm not going to give you such a murky question.
Okay.
Don't worry about it.
That's
Yeah. All right, so if you turn the page, you might get a head start on the reading, because there's a lot of words on the next page. I know.
Need a new prescription to go after. Let's see.
All right, let's look at the next page. All right, Spearman's rank correlation coefficient. I'm going to tell you what it is really quickly before we go to all the words, because it will help you make sense of the words. When you do a Spearman's rank correlation coefficient, instead of using the actual numbers, you just rank them in order from smallest to largest. So if the numbers were like 5, 10, 20, 30, you would put the 5 as 1, and the 10 is 2, and the 20 is 3, and the 30 is 4. You would use these numbers and find the correlation coefficient of the ranks. Okay, there are some things that are a little tricky about it, but that's basically what you're doing. So sometimes we're given data that while a strong but not perfect correlation, we might not be convinced that a linear model is appropriate. So remember we said that we only use R for linear models. R squared, we'll use that next class for nonlinear models. So if we want to use R, we can focus on just the upward or downward trend of the data. For example, is the data always increasing? Is the data always decreasing? Or is it kind of scattered all over the place? Data could be always increasing, and maybe it looks like exponential, for example. And that would not be a strong linear pattern, but it is a strong increasing pattern. So one way to do this is to consider the relationship between each variable's ranks instead of the raw values. A rank is an assigned value for each x and y value based on how small it is. A rank of 1 corresponds to the smallest value, and a rank of 2 would be the second smallest, and so on. After assigning the ranks, we can graph the data based on the rank, which will result in a more linear appearance that would allow us to evaluate the trend of the data. So you can imagine if you're just ranking the data in order and the data are consistently increasing, then your points would now look linear if you're using like 1, 2, 3, 4 instead of using 1, 2, 4, 8, 16, 32. Okay? Okay, so where was I? Spearman's rank correlation coefficient of a bivariate data set is defined as the Pearson's product moment correlation coefficient of the variable's ranks. So you do the exact same thing, but you just use the ranks. To distinguish between Spearman's ranks and Pearson's ranks, it's common to use R sub S and R sub P respectively. Since Spearman's correlation only considers the relationship between the ranks and not the data itself, R sub S is often used instead of R sub P when the data is clearly non-linear, but has an upward or downward trend. So, To draw the scatter plot, what we're going to do is first plot it and just draw a sketch of the scatter plot because I don't need it to be exact. I just want to see its shape, okay? So we're going to put this in list 1, and we're going to put this in list 2, and we're going to draw a scatter diagram for the data. We have not been asked to rank the data yet, so don't worry about that. So go ahead and put that in your calculator. I do not have. All right, so to do the scatter plot, make sure that your stat plot is on. To make sure your stat plot's on, you do second and y equals. And then press enter and turn this on if it's not on. And then you're gonna do zoom stat. And I'm hoping that that is actually list 1 and list 2. Does yours look like that? Yeah, good, okay. All right. Yeah. So let me show you one more time. You already got the data in your list? Okay. So once the data is in your list, press second y equals to make sure your plots are on. Are your plots on? If it's off, then yes, you press enter. And then you press enter on the on. And then you can press enter through all of that. Then sometimes you can press graph and see it, but mostly it doesn't show up. So you go to zoom stat, which is 9. And then you should be able to see it. Okay. All right, so we're going to do a quick sketch of this graph. Would you say that that looks linear? No. Does not look linear, which is good, because it means we get to practice our Spearman's rank. Okay, so I probably put too many points in there, but I just wanted to get the shape of the graph in there, so you should get that as well. Okay, for B, we're gonna find R, and we're calling it R sub P because it's Pearson's. That's the one from last lesson. So you're gonna go back to your calculator, and we're gonna do stat calculate. And we'll do the linear regression, which is 4. And just like in the warm-up, we're going to find R. So I get R is 0.860. Is that what you guys got? Yeah. Okay. So now it's telling us to find ranks. So if you look at the t-values, I think they're in order. And so we're just going to number them 1, 2, 3, etc. Oops, you guys can't see that. I'll show you. So these numbers were in order, so we just numbered them 1 through 9. The p-values are kind of in order to start with, but then they kind of get out of order. 1030 is the smallest, so that gets 1, okay? I want you to go through and try to order these. And then what we're going to do is use the ranks to find the Spearman's rank correlation coefficient. Okay, so the first 5 were in order, and then the next one was this one. And then this one, and then this one, and then finally this one. All right, so then you're going to be using these two as your list 1 and your list 2, and you'll find R. All right, so just because I wanted to be ready ahead of time, I put those values in my list 3 and my list 4. Here, list 3 and list 4. But you guys, you can clear your list 1 and list 2, and you can keep them in list 1 and list 2. But because they're in list 3 and list 4, when I do stat calculate linreg, then I have to change these to list 3 and list 4. You don't have to do that if you just clear out your lists. So list 3, and then list 4. All right, so I'm getting 0.933. Did you guys get 0.933? Okay. So that kind of shows better that there is a clear positive trend, even though it's not linear. So R sub S is 0.933. All right, so then if you turn the page, it says, which correlation coefficient is more appropriate to use for this data? Explain your answer. And that kind of question is just asking you about whether the data are linear or not. Would you say that this data set is linear? We already answered that, right? We looked at the graph and we said it's not linear. So since the data set is not linear, then we can say Spearman's rank is more appropriate. And then since we're using Spearman's rank, we're going to make our conclusion from the R sub S and not from the R sub P. So our R sub S was 0.933. And that should tell us that there is, was that strong or was that very strong? Very strong?
Okay,
No strong?
strong.
Strong, okay. All right. Based on R sub S, there is a very strong, nope,
Just
strong,
strong.
just
Yep.
strong. Positive.
Feels like it should be very strong.
Yeah, not quite there though. Correlation between the variables. All right. And next we have a thinking activity, but luckily it's not a paragraph of writing.
Thing.
So it says match each diagram with its correct rank scatter diagram. So the first one would be R sub P, and then the second one would be the ranks graphed, actually, not the R's, but it would be the X and Y graphed, and then the ranks graphed. And there's going to be a correlation. And remember, like, when you take the ranks, it's going to make your data look more linear.
Yeah, that's the change.
So the first one, if we change it to graph only their ranks, would it match A, B, or C? I heard a vote for B. Anybody agree with B? Yes. So remember, by ranking it, it will look more linear, but it will have the same downwards trend. So this one should be B. What about this one? C, yeah, C is right. Because it's going to have the same upward trend, but it's going to look more linear. And interestingly, it looks perfectly linear, and that's because these points never decrease. They're always increasing. These were not perfect because they were increasing and decreasing a little bit, but these turn out perfectly once you change it to a Spearman's rank. This one would be what? A. And notice, you can't make everything look linear. If it's all up and down all over the place, it's not going to make any more sense when you change it to Spearman's rank, okay? So Spearman's rank will not lie to you and tell you that there's a pattern where there's not a pattern, okay? All right. Next part, ranks of tiered values. In some cases, we have X and Y values that are equal, and these are called ties. That makes sense, right? So they can be the values in a tie rank. To do this, the unique values are assigned ranks, which will leave our values for the ties, and then the average of the lengths of them. So we had a tie of 7 and 7, and so we ordered 1, 3, 4, and then these would have been 5 and 6. Average to 5. So at the rank of 5.5. It can be tricky because if you're going in order and you get to this and you say 5.5, it's tempting to make the next one 6, but it's not. 5.5 is the average of the 5 and the 6, and so the next. Questions on that? Because I'm in order, right? And these two are tied. So because they're tied, we have the same number. And that would be between where they would have been. So one of them would have been 6. When you put them together, the average of the 5 and the 6. Ready? One sec. Turn the page. So I think I put this one into my list 5 and 6, but my question is, can I graph that now? So I want to see, oh, I know what I have to do. I have to go second, stat plot, and I need to change it so it's gonna be doing 5 and 6. So I'm gonna go down. Now you guys are hopefully still in list 1 and list 2, so you don't have to worry about this, but I'm gonna go to list 5 and list 6. Okay, and then I'm gonna do zoom stat. Mine looks like that. Anybody else get that yet? Okay, so it does seem to be increasing, not quite linear, but maybe linear-ish. It's definitely not exponential. I might call that linear-ish. We're gonna see, okay? So I'm gonna sketch that onto my paper. Yeah, so if they would line up in a straight line, they would be perfectly linear. This one is kind of close. Okay, let's do R sub P to see if Pearson's coefficient agrees that we have a strong linear correlation. So I'm actually going to do that before I go back to B. So I'm going to do stat, calculate, and linreg. Oops, I need to make these list 5 and 6 for me. Only because that's where my data is. It's 5. Oops, not that one. Okay. List 6. So already my R sub P is 0.943, which is already strong. Okay. So I'm not too worried about having to do Spearman's. So we're going to also find R sub S. And then here it says, oh, you're not looking at my pix. It says, use the scatter diagram to explain why you would expect and Spearman's correlate similar values. So they're telling us that, which means that this must be pretty linear. So I would say the graph is approximately linear. So the values to be similar. All right, take a minute and see if you got the same rankings I got. And then once you get the rankings, if you disagree, let me know. And then once we agree on rankings, then you, I don't know why, but my key says 0.97. Is it 0.970? Yeah? Okay. 0.970. Are we agreeing?
Yeah.
Okay. All right. So they are similar, just like we